What if I told you that right now, across Europe, something is being built that could completely change how an entire continent moves, trades, and even defends itself, and most people have no idea it's happening? Not a single project, not just one railway or tunnel, but a massive interconnected system designed to make Europe function like one unified machine. And if you stick with me, you'll see exactly how this network works, how it's being built piece by piece, and why it might be the closest thing we've ever seen to a United States of Europe. The United States transformed itself with its interstate highways. China reshaped travel with its high-speed rail revolution. But Europe is attempting something even more ambitious: a $600 billion network of railways, tunnels, bridges, and logistics systems that will bind dozens of countries into a single, seamless transport grid. This is the TEN-T network, and it's not just infrastructure, it's a complete reimagining of how a continent operates. To understand how massive this is, you have to start at one of the most unlikely construction sites in the world, where Germany meets Denmark in the cold, restless waters of the Baltic Sea. At first glance, it seems impossible. They aren't drilling deep beneath the ocean like traditional tunnels. Instead, they're building the tunnel somewhere else entirely, and then placing it into the sea. In what is effectively the largest concrete factory ever created, enormous tunnel sections are being constructed one after another. Each one weighs around 73,000 tons. To put that into perspective, a single section is comparable in size and weight to a skyscraper laid horizontally. And yet, every piece has to be perfectly engineered, because once it's placed underwater, there's no margin for error. The process begins with steel. Not just any steel structure, but a dense, carefully designed skeleton that forms the internal framework of the tunnel. Workers spend weeks assembling this intricate cage, ensuring it can handle the crushing pressure of the ocean above. Once that's complete, massive molds are set around it, preparing it for the next stage, the concrete pour. This isn't a simple job. The pouring process runs continuously for 36 hours. It cannot stop. If it does, even briefly, it could weaken the entire structure. The concrete itself is specially designed to survive over a century in a harsh saltwater environment. Every mixture, every layer, every second is calculated. When the concrete sets, what emerges is not just a solid block, but a hollow structure containing space for both a highway and a double-track railway. The ends are sealed off with enormous steel doors, effectively turning the structure into a giant watertight vessel. And here's where things get even more surprising. To move something this massive, they don't rely on brute force, they rely on physics. By sealing it and controlling its buoyancy, the entire 73,000-ton structure floats. Then begins a slow, almost surreal journey. Tugboats guide these floating giants out into open water, carefully navigating them toward their final destination. Meanwhile, beneath the waves, another team is preparing the seabed. A trench stretching miles has been dredged and is being lined with gravel, leveled with astonishing precision, down to mere centimeters. When the floating section arrives, it's positioned using GPS systems with extreme accuracy. Then comes the most delicate phase, the descent. By gradually filling ballast tanks with water, the structure is gently lowered to the ocean floor, guided by divers and computer systems. It sinks, slowly and precisely, until it aligns perfectly with the previously placed section. Once in position, powerful hydraulic systems push the sections together, forcing out water and creating a tight seal. Over time, the pressure of the surrounding ocean itself reinforces the connection, locking the pieces together into a continuous structure. And this isn't done once or twice. It's repeated again and again, nearly 90 times, until an entire tunnel stretches across the seabed. A highway and railway hidden beneath the sea, connecting nations in minutes instead of hours. But this is just one piece of the story. From the ocean floor, the focus shifts to the towering Alps, where another challenge has slowed Europe's connectivity for decades. The Brenner Pass has long been one of the busiest trade routes in the region, but it comes with a cost: traffic congestion, pollution, and slow travel through winding mountain roads. The solution isn't to improve the roads, it's to bypass the problem entirely. Instead of going over the mountains, engineers decided to go straight through them. The result is a 40-mile-long base tunnel carved deep beneath the Alps, creating a direct, flat route for high-speed trains. To build something like this, you need machines that feel almost unreal. Tunnel boring machines, or TBMs, are essentially underground factories. At the front, massive rotating cutter heads grind through solid rock, even granite, reducing it to rubble. Behind them, conveyor systems carry away the debris, while new tunnel linings are installed almost simultaneously. It's a continuous process, digging and building at the same time. Operating one of these machines is like piloting a spacecraft through stone. Engineers rely on lasers, sensors, and precise calculations to guide the TBM through miles of solid earth. And as it advances, it leaves behind a perfectly formed tunnel lined with concrete rings designed to withstand immense pressure. But the mountain doesn't make it easy. At any moment, the machine can encounter unstable rock or underground water under high pressure. When that happens, everything becomes dangerous. Water can burst through unexpectedly, threatening to flood the tunnel. Crews have to act quickly, injecting chemical grouts to seal leaks and stabilize the surrounding rock before continuing. The tunnel is being dug from both ends, with two teams racing towards each other. After years of work, they finally meet deep underground, their alignment accurate to just a few centimeters. It's a moment that represents not just engineering precision, but persistence. With the tunnel complete, what was once a slow and difficult journey through mountains becomes a fast, efficient route for high-speed trains. Trains can now pass through the Alps in a fraction of the time, reducing congestion and cutting emissions. And then, further east, another transformation is underway, one that's just as important, but for very different reasons. In the Baltic region, railways have long been shaped by history. Built during the Soviet era, the tracks use a different gauge than the rest of Europe. This seemingly small difference creates a massive barrier. Trains can't move freely between systems, forcing delays, transfers, and inefficiencies. To fix this, an entirely new railway is being built from scratch. It's not just an upgrade, it's a complete replacement. Old tracks are torn out, and new ones are laid with modern standards, allowing high-speed travel and seamless integration with the rest of Europe. But this project isn't just about economics or convenience. Recent geopolitical tensions have highlighted another critical need: mobility. This new railway is being designed to handle not just passengers and cargo, but heavy military equipment. It allows rapid movement across the region, strengthening security and response capabilities. At the same time, the project incorporates environmental considerations. Special wildlife crossings are built to allow animals to move safely across the landscape, ensuring that the railway doesn't disrupt natural ecosystems. And along the route, new transport hubs are rising, modern stations that will become central nodes in this growing network. Meanwhile, back at the tunnel construction sites, work never stops. New sections are constantly being built, tested, and launched. Every component is checked repeatedly. Rubber seals must remain effective for over a century. Ventilation systems powerful enough to move air through miles of tunnel are installed. Emergency systems are built at regular intervals to ensure safety. Every detail matters. The tunnels are equipped with thousands of sensors, creating digital models that allow engineers to monitor conditions in real time. Lighting systems stretch endlessly through the darkness. Tracks are welded into seamless lines for smoother, faster travel. Even after construction, maintenance teams move in first, testing every system before opening it to the public. And slowly, piece by piece, the network comes to life. A car enters a tunnel beneath the sea, completing a journey that once required a ferry. A train speeds through a mountain, cutting travel time dramatically. A new rail line connects regions that were once isolated. What used to be separate systems, divided by geography and history, are becoming one. The impact is immediate. Fewer trucks clog mountain roads. Trade flows more efficiently. Travel becomes faster and more reliable. Entire regions become more connected, more accessible, and more economically integrated. And yet, what's most remarkable is that all of this, every tunnel, every track, every bridge, is part of a much larger vision. The TEN-T network isn't just about infrastructure, it's about creating a unified system that spans an entire continent. A network that functions like a single organism, moving people, goods, and even strategic resources seamlessly from one end of Europe to the other. As the 2030 deadline approaches, construction continues around the clock. Across countries, across landscapes, across oceans and mountains, thousands of workers and engineers are contributing to something unprecedented. This isn't just building roads or railways, it's building the physical foundation of a more connected Europe. And while it may not be called a United States, the idea behind it is strikingly similar, a system that binds diverse regions together into something stronger, faster, and more unified. What you're seeing isn't just construction, it's transformation. And the most fascinating part? It's still happening. The next section is already being built.